Yeah, if you get something like this RHS, you can use this idea. But the PI of this one, okay, so in case of PI, I'll give you, okay. I think I need to give it 3 more PIs, okay. So please write down this results of integral calculus. So if you get these, it will be it is equal to this one, okay. You can transform this one into this, okay. So you can try to find how it is coming, okay. So it is using the integral ideas, okay. So if you have extra PIs, okay, just note down. If you are having something like this, okay, 1 over f of d comma d dash time e to the power ax plus by time one function pi of x comma y. In this case, okay, this is what I told you earlier. So you can use e to the power ax plus by. So we don't consider this one, okay. We're going to transform, okay, the f as, for the d, you have to make the chain d plus a. Okay, for the d dash, you have to chain d dash plus b. And again, the pi of x comma y. So you need to know this is a coefficient we are adding for the d. So according to that, it may change. The function will be changed. Okay. So you can find some examples regarding this. For time being, I'm skipping those, but you can try. Okay. So this is one of the rules. So these are PI rules. Okay. Some extras. Also, what if you get d minus md dash? Okay. Something like that with f of x comma y, one function. Okay. So in that case, you have to transform this, the PI will be integral of whatever the function f, okay, x will be x as it is. The y can be changed into c minus mx dx. How they have taken this one? Where c is equal to y plus mx. Okay. So, yeah. So what they have done is this m has been transformed to this y as a plus mx. Okay. So these are a little bit critical things, but just for your knowledge, okay. See whether you can find some examples regarding this. I'm just giving all the rules just for your knowledge, okay. F of x same dx. So this is plus minus also plus also same thing, okay. Yeah, sorry. Yeah, give me a second. What if where she is equal to y minus mx? Is that possible? Y is equal to, so it should be plus. I think there's a mistake. Okay. Okay. So it's just the rules. So wherever possible, you can use it. Okay, I'm just finishing this because we need to go for some extra things. Okay. So have you written this one? So what's that problem? 2 times sine 3x 2y. Okay, now I gave you now. So I got one question in the last class exercise. One of the question she couldn't understand the PI part. Okay, let me just give you the idea, because the thing is, okay, now only I gave you that one. Listen, PI is our 1 over d cube minus 4d square d dash plus 4d d dash square. Okay, so it is something mix up. Okay, with we have the RHS sine 3x plus 2y. Okay, so in this case, we have to take d squared as minus square, d dash square as minus b square. Also, since this is like a sine a plus b, no, a plus b. So I gave you now the idea. Similarly, d dash will be minus ab. Okay. So what they have done is, for the, yeah, a is equal to 3, b is equal to 2. Okay. So they have, in this, we have d cube, no. So actually, this is the third order. Okay. We are just studying for, general idea. So I just gave you to just try. Okay. But anyway, we are just restricted our course for the second order. So maybe the exams we will consider that one for exercise purposes. Okay. So d cube. Okay. But we only d cube means what? D cube will be d into d squared. No, I'm just taking d squared only. Okay, give me a second. Okay. Okay. So I have the d. What is d squared? Minus 9. Okay, minus 9. Okay. Minus 4d d square d dash. So I'm just taking 4d into d dash, and I taking d as it is. Okay. Did you understand? So here 4 times for the d dash. So d is there. Okay. For the d dash, I can put what is that? Minus ab. So minus 3 times 2, 6. Okay. So 24. Sorry. They have written like this. So that's what the problem. Okay, give me a second. So you can try anyway, but they have given the answer in this way. That's why I wrote that way. You can also take d dash, or they have taken d squared first. Okay. For the d squared only, they have put minus 9. Okay. Minus 9 d dash, and then 4d. Okay. D dash squared. So minus b, which will be minus 4. Okay. So what will be the final? So minus 9d. So plus 36d dash minus 16d. Okay. So all the RHS terms will come. So here then we have, they have did is, they added this one. So 1 over 36d dash minus 16 plus 9, 25, no? 25d. Okay, times this one. Okay. So far good. So we have did this already. So I'm just giving the idea. Okay. So after that, they have did a rationalization. It means we have this one, no, 36d dash minus 25d something, which RHS. Okay. So but we already have the answer for this one, a squared, d dash squared minus b squared, something like this. So what they are doing is, like they are multiplying with, like if you have a minus b, what do you do? To get the a squared, b squared, something, you have to multiply with a plus b, isn't it? So it will get a plus b divided by a squared minus b squared. So that is we called as a rationalization. Okay, so that's what they have did. Okay, you 36d dash plus 25d, you multiply. So you will get 36d dash plus 25d divided by 36d dash squared minus, so a squared minus b squared, no. So minus 25d whole thing square. Okay, times RHS. So here, what is this? 36 times 36 squared will be something. You just do the calculation. Okay, just the calculation. Okay, I think it's not finished. Anyway, I think this is enough somehow. It takes too much work, no? So leave it. So I will find the answer anyway. Last answer and give to you. Okay, so I'm just stopping here for this one. Okay, so and also what we have. Who's talking? Can you off your mic? Okay, now, so what I have meant by homogeneous and PDE, homogeneous linear PDE, how we have to understand, find out whether it is homogeneous linear PDE. How to find it? I told you today also. How you can find out whether the PDE has given is a homogeneous. Anyone? I told you, like, for example, A naught da bar n z da bar xn plus something. Okay, all will be in the same degree, same order. Okay, all the terms will be in the same order. The last one will be an da bar nz over da bar yn, isn't it? All the order will be, if you add, so whatever the order for the numerator will be the denominator, no? So then only we can find. So if you check all the, terms, it will have same terms. Okay, yeah. So in that sense, so what if it is non-homogeneous? So I think we also use this, definition in our EDE also, elementary differential equation solving techniques, homogeneous solving technique also. We have checked whether the xy plus, like that. So x squared, whatever you have here, it should be, this term will be 1, 1, 2. This one, 2. This one will be 2. Something like we check, no? So that's the idea, okay? So what about the non-homogeneous? What do you think? So if it is all the terms are same, it is a homogeneous. And what about the non-homogeneous? So you must have any of the term is not, satisfy this, no? Okay. In that case, we have to do some extra works to reduce to the homogeneous case, and it has, it's going something. Okay. But for now, the time limit, I'm just omitting these things for now, but it is your exercise. Okay. But the exercise is, okay, you have to find how to solve non-homogeneous linear PDE with constant coefficients. Okay, just refer this one. If time permits, we can check later, but for now, I'm just giving you as an exercise. You just, take down the notes, same idea, but a little bit work for the reductions. Okay, so we have to reduce reduce that for some ideas. Okay, that is your exercise. So let's continue our chapter 3 with section 2. So I'm trying, I couldn't find some time to, type the things, but I would like to write it. So please write with me, okay? So our section 2 is in the chapter 3, okay, is classifications. Classification of second order PDE. Classification as well as canonical form also is coming here, okay? So two sections covering here, canonical forms, okay? So with this, we can finish this chapter. Okay, so let me continue because it has so many things to deal with. So I will write here, okay? Please write with me, possibly quickly, okay? So the general, okay, mostly the general case of second order PDEs in two independent variables, let's say x comma y, okay, is given by, okay. So let's see how, so in our homogeneous case, we have seen the second or, nth order equation, and then we have found a way to solve it. But you can, because since our chapter 3 is regarding the second order, the question will come up to second order, so you don't need to worry about the extra orders, but it's better you to study for any orders, okay? So but in here we're going to restrict our case to second order. So in that sense, the general general equation will be, okay, let's see, a, let's write the coefficient kept a b c d, okay, a times da bar squared, since we are doing second order, so da bar squared u over da bar x squared. Let's take b is equal to da bar squared u over da bar x da bar y. Okay, maybe it is a capital U or small u. Okay, don't combine both. You write capital U or either small u. Okay, so here we our independent variable we are taking as a u. Okay, so u can be a function of x comma y. Okay, and then C, it continues da bar squared u over da bar y squared. So here I'm taking as da bar squared u, da bar x, da bar y. These are some points you can note it down. Okay, da bar squared u, da bar x, da bar y, which is equal to da bar squared u, da bar y, da bar x. Therefore, if your same thing come, it will be come to 1 plus 1, 2, no? So it will come to this constant. So I'm taking both are equal in this case, okay? Also see da bar squared u over da bar y squared. Also, this is the second order now. So in the second order cases, we may have second order as well as first order, as well as some, dependent variable function, as well as some constant, isn't it? So we need to write that one also. So d times maybe da bar u over da bar x will come, and e times da bar u over da bar y can be comes, and also some function of u with constant, and also any constant also, okay? So this is our main equation of second order PDE, okay, with two variables, x and y. So where you can write where A, B, C, D, and E and F are functions of x and y as well, okay. So maybe something like x square plus 2y, okay, any functions, but not depend on u, okay. Similarly, this can be any constant, okay. So I'm not using g here, okay. Function of x and y. And do not vanish simultaneously. So that is also one of the conditions. Simultaneously, okay. Okay, what do you think about this one? Do not, these A, B, C, D, E, F, not, do not vanish means not equal to 0. Okay, not equal to 0 at the same time. Okay, simultaneous means same time. So what that says is, so let's say if all the A, B, C, D, everything is 0, this is not a second order case, no? Okay, what about A and C are 0? Still okay, isn't it? Only A, B, C are 0. So we can't say this is not a, I can say this is not second order, but first order, okay? So you have to make sure this is not vanishing, I mean, not equal to 0 at the same time, okay? Okay, let me continue this one. So please write down quickly or take the screenshots. So this equation also can be written as, okay, ax comma y. So I'm gonna make it simpler form, okay? So now I'm gonna use some, because of this function, I'm gonna use, I can use this notation now. So I hope you understand this notation well. So u, y, y. So I'm gonna use all these other terms, okay? Only I'm gonna keep the second order this side. All the first order and coefficient and all other terms I'm taking as a pi of x, y, maybe a u, ux, uy, everything I'm taking this side as a function of pi, okay? So you can write this one as a question, equation number 2. Okay. So already we have seen for first order and any orders in the classification, in the sense, what is the type, what is the, degree, order, and non-linear, non-linear, and homogeneous or non-homogeneous. These cases also we have seen for general idea. But for the second order PDE, we are going to, fundamentally we are going to divide these, classify these in the 3 types. Okay. Not this type, I mean PDOD. This is already OD, I mean PDE. But here for the second order, we're gonna divide this in 3 cases. Okay. So I will write the notes in the next window. So write down. There are, just write down yourself. There are fundamentally 3 types of second order PDEs. 3 types of second order PDE. Okay, 3 types. So let's see what are the types. First of all, we call it as a hyperbolic. Okay, hyperbolic. Which is in the physical way, it says wave equations. Okay. Second one is a parabolic. Hyperbolic, you can write hyperbolic equations or parabolic equation, which has a physical interpretation of heat equation. Okay. And the last one we called as a elliptic equation. So this will be something like Laplace equation. So we can see what it is later. In our chapter 4, it's all about solving this one. Okay. So first, let's understand the concept, how we can, classify this in this chapter, then we can solve this in the chapter 4. Okay. So these are the fundamental three types of second order PDEs: hyperbolic, parabolic, elliptic. Okay. So don't forget, hyperbolic is a wave equation, parabolic heat equation, elliptic can be Laplace equations. These are physical interpretation, you can say. Okay. Okay. Now let's continue. So write down, mathematically, these classification of second order PDEs, you can write capital PD. Okay. Mathematically, this classification of second order PDEs is based upon the possibility of reducing the equation number 2 by coordinate transformation. Okay, so they are deriving this classification using a coordinate transformation. So do you remember we have seen some coordinate transformations, curvilinear, Cartesian to curvilinear coordinates in our vector calculus courses. But here we are going to use some other techniques, which is also called as a coordinate transformation. Okay. Mathematically, these classification of second order PDEs is based upon the possibility of reducing the equation number 2 by coordinate transformation to canonical, or we also say standard form. Okay, canonical or standard form at a point. In some point, we are going to make that equation number 2 to the canonical or standard form. Okay. Okay, I think our meeting also going to finish. We can continue. Okay. So write down the next point. The types of second order PDE. So in the equation number 2, okay, at a point, for example, any point we can take y x naught comma y naught. Okay, depends. Okay, so how we can find from second order to this type is at a point it just depends on the sign of the discriminant. Okay, what do you mean by discriminant? Anyone? Discriminant means what? Yes, the others. Everyone, after attendance, everyone gone? Nobody answering? So what do you mean by discriminant? Please answer me. For example, the second order equation, we just for understanding, I'm just telling x square plus 2x minus 1 is just equal to 0. This is also one of the second order algebraic equation. Okay, just compare this. Okay, so what is the discriminant of this one? You have idea? So for example, quadratic equation we can write as a square plus bx plus c is equal to 0, isn't it? So what do you call as a discriminant? or delta is equal to what? Yeah, only one has answer. What do you mean by delta? So for the when you're solving this one, we have one equation, no? Minus b plus or minus square root of delta divided by 2a. Okay, what is this delta? What do you mean by 8? Yes. Okay. So b squared minus 4ac we called as a discriminant. So don't forget it. Okay, delta is equal to b squared minus 4ac. So these techniques we're going to use for second order also. Second also like this equation, no? A times da by square x is, u over da by x square plus b times something plus c times something, no? So we are going to consider, not actually, but for the understanding, okay? So this is we called as a discriminant. This discriminant, okay, in this, solving techniques, do you remember according to the delta, our question, answer roots will be changed, no? So what if it is delta greater than 0? What if it is delta less than 0? What if it is delta equal to 0? So we have studied this one in our school, no? Or even A level. So delta greater than 0, what kind of roots you may get? Can you remember? So see here, we have minus b over 2a plus or minus delta. So it's inside the root, no? So we have the root always should be positive. If it is negative, whatever the negative comes, it will be a no complex number. So if you are putting minus, it will goes to something delta will be, according to delta greater than 0, then you will have a positive, inside this one will be positive. So you will get two, distinct, am I right? Two roots, okay? Two roots of distinct roots, okay? Yeah, real, but different. Okay, good. What about, is that less 0 is real and different? Can you check? What if it is inside the delta is, minus, something minus. Okay, something, it will be complex, no? It will be complex. Okay. Yeah. What about just equal to 0? You will have minus b over 2a only. So this term will be 0. So we'll have, so square root of 0 will be 0, no? So this will be like minus 2 over b over 2a, b over 2a. So even though we should have two solution, no? So it will be repeated one. So repeated as well as real. Okay. Okay, this will be complex. Okay. So in that things also applicable here. Okay, according to that only we are dividing this classification, like what is hyperbolic, what is parabolic, what is elliptic. Okay, according to this kind of knowledge. Okay, so I'm just use this one for your knowledge. Okay, the same idea anyway, but you can compare your ideas. Okay, so let me have you written this one. So according to discriminant. Okay, so let me continue the notes first of all. Okay. Yeah. Write down the types of second order PDE2. Okay, I think I have written you. So discriminant defined as so delta of at the point. So you can write like this: at the point x naught comma y naught, which is equal to b square minus 4ac. That is also written in this way. So because of the determinant only we are getting, so we don't use this technique, but the thing is how this is how it came. Okay, 2a, I think 2c, this is b. See what is the determinant of second, 2 cross 2 matrix, b square, this minus this, no, b into b square minus 2 into 2 4 ac. Okay, this is the idea they have get this. Okay. Okay, so you can use this one as b squared of x naught comma y naught So at that point only, no, we are considering. So A times X naught Y naught times C, since we are taking all the A, B, C as the function of X comma Y. Okay. So this is equation number 3. You can write that. Okay, now, so we need to finish. So I'm going faster. Okay. So the classifications. So now we are coming to classifications. Classifications. Classification is given by the following. That is, if, okay, if you have the discriminant, okay, so please use this word again, so then you won't forget, okay. So rather than delta, you use discriminant, okay. If the case is discriminant greater than 0, as like in our case 2 real root, okay. So here we call this as a hyperbolic equation. We can see how we can derive all these things later, okay. As well as if the case is equal to 0, we call that one as a parabolic, okay, parabolic equation. Similarly, if the case of less than 0, we call it as a next one, elliptic, okay. Okay, now let me continue. So as I said you, we have the equation number 2, okay. So if you wanted to find whether it is which form it is, okay, to get the canonical form, I told you we need to use a coordinate transformation, okay. So that's what we're gonna do now, okay. So please write down, in order to illustrate the significance of the discriminant, okay, discriminant delta, and thus the classifications to get the